Hey everybody, welcome back to Mr. A's Geometry course. Today we're covering section 4.3 of geometry, which is all about rotations. Let's get into it. A rotation is a rigid transformation. So remember, that means it's going to create a congruent figure. It's not going to change the size of the shape. It's just going to move it to a different position, right? And the way that it moves is by turning that figure around a center of rotation. So as we see the example over here, our pre-image A is turning around that center of rotation right here a certain amount of degrees. And that's what we're going to be learning today, is how to turn figures a certain amount of degrees on a coordinate plane. Now the directions that we can turn, there's two of them, right? The common one, the default direction that we turn when we rotate figures is counterclockwise. Counterclockwise. The abbreviation we're going to use for that is CCW, and then obviously the other direction that we can turn is just clockwise, the way a handheld clock will turn. All right, we have two examples of that over here. So point R is the center of rotation. Turning this way around that point is counterclockwise. Turning this way is clockwise. So again, counterclockwise is like steering your car to the left. Clockwise is like steering your car to the right. We are going to be turning our points around the origin today. So the point 0, 0 on the coordinate plane. And it's very important to note here, if we're not told which way to turn or rotate our figure, then our default direction is going to be counterclockwise, which is the same ways that our quadrants rotate. We start with quadrant 1 in the top right, quadrant 2 in the top left. Our quadrants go counterclockwise, so if it doesn't tell us which way to rotate, we do it the way the quadrants go, counterclockwise. There are three types of rotations that we need to learn about here today. And if you're one of my students following along in your packet, I actually made a huge typo in these rotations as we go through. I accidentally put clockwises before counterclockwise in the packet. We need to make this change here, very important. We're going to talk about counterclockwise with our first number throughout our notes here, and clockwise with our second number. And they'll explain here why these are the same thing here. 90 degrees counterclockwise is the same thing as 270 degrees clockwise. I'll use this yellow paper here as a reference. So here's the top of my paper. Every 90 degrees we rotate is going to be a quarter of a turn in either direction. So if we're going counterclockwise, it's turning to the left. So 90 degrees is just a single quarter of a turn to the left. And that top of my paper now is facing me. That's 90 degrees counterclockwise, okay? 270 clockwise is the same thing. So again, 90 degrees is a quarter turn. Clockwise is turning to the right. So we'll do this for a total of 270. So 90 is a quarter turn to the right. My top is facing the right. Another 90 gives me 180, where the top is facing down. Another 90 gives me 270 degrees, and again, the top is facing me. So going 270 clockwise is the same thing as 90 counterclockwise. On our graph here, we have an example of a 90 degree counterclockwise or a 270 clockwise rotation occurring. Right, as we zoom in, we can see how our coordinates have changed here. So on our pre-image, let's look at point H. Point H is located at -3, +1. If we look at H prime now, that's located at -1, -3. All right, and so there's a hint as what happens here anytime we rotate 90 degrees counterclockwise in these coordinates. Notice the 3 and the 1 have switched places, so that means my X and my Y have switched. That -3 stayed a -3, but that +Y became a -Y. +1 became -1. So the rule here, anytime we rotate 90 degrees counterclockwise, is that our pre-image XY will flip. So the Y will come first, the X will come second, and the Y coordinate will change its sign. So a 90 degrees counterclockwise rotation, X and Y flip, Y changes its sign. Very important note here. For every 90 degrees the point rotates, it is going to move exactly one quadrant. And we can see how that happens here in our figure. Point H was in quadrant 2, H prime ended up in quadrant 3. It moved one quadrant. All right, our other points F and G on our pre-image were here in quadrant 3. They rotated into quadrant 4, exactly one quadrant of movement. This will always happen for every 90 degrees that you rotate. In our first example here, we're asked to rotate this segment 90 degrees. It doesn't tell us which direction, so as a reminder, if it doesn't tell us the direction, we will always go counterclockwise, 90 degrees counterclockwise here. And again, using the function notation rule I just taught you, xy becomes negative yx, we can perform this rotation without doing it by hand, which I'll show you later. Okay, so I can look at my pre-image, point A was located at -3, +4. If I flip those coordinates to get to A prime and I change the sign of my y, I will end up at -4 and -3. So again, the 3 and the 4 switch places, the y changed its sign, the x kept the same sign. That would be the rotation for point A. So I can graph that, -4, -3 would end up right here for A prime. Then point B on our pre-image was located at +2, -3. And if I perform that same change, flipping my x and y coordinates and changing the sign of my y, my -3 will flip up front and I'll change the sign to +3. The x flips to the back and it keeps the same sign. So B prime would be at +3, +2. Right there is B prime, and there is the 90-degree rotation of that segment. Now I'm going to show you how we can do this same rotation by hand without memorizing function notation. As a reminder, we're talking about a piece of paper. When I rotate it, every 90 degrees is a quarter of a turn. So if I'm going to go 90 counterclockwise, that would be taking my paper and physically turning it a quarter of a turn to the left. So if we have physical graph paper, I'm going to show you how we can actually figure out where our image needs to be by doing this, by literally rotating our paper in hand. So top of your paper pointing to the left, that's 90 degrees counterclockwise. I'm going to do the same thing here on my software. I can actually mess with the size and position. The default rotation here is clockwise, so I'm going to be doing 270 clockwise. That'll be the same thing as 90 counterclockwise. And watch as it changes my figure. Right? Just like we did before, it's taking the graph and turning it so that the top is facing this way. And so if this is what your paper looks like now, you now have the locations of your image. What we're doing is imagining that we haven't turned our paper at all, and we can see where our coordinates are located. For example, A from the origin, if I'm imagining that this is still y-axis, x-axis with no change, my point A is 4 to the left, 3 down. It's -4, -3, which is exactly where our A prime ended up. Our point B from the origin is 3 right, 2 up. And so if we memorize these directions, we can turn our paper back normal, back to its original position, and we can graph those points. 4 to the left, 3 down for A prime, 3 to the right, 2 up for B prime. So you can turn by hand and perform all of these rotations. All right, in our next example here, we're going to rotate triangle ABC 270 degrees clockwise. Again, that's the same thing as 90 degrees counterclockwise. And again, we're going to first perform this using the function notation rule. All right, so that's xy becomes -yx. We know the location of A on our pre-image is at -5, +4. If I switch those and change my y sign, I'll end up at -4, -5. So that's left 4, down 5. That would be right here for my A prime. And that moves exactly 1 quadrant like we expected to. B is at 0, 2. If I perform my function notation rule there to get to B prime, my x and y will switch, my y will change sign, so that would be -2, 0. -2, 0 is right there. So there's B prime. Now B was on an axis, right? And so for 90 degrees, when you're on an axis, you're just gonna move to the adjacent axis in that direction. So I went from the y-axis to the x-axis, 1 axis over, still 1 quadrant of movement there for B. My pre-image point C was at -2, -3. If I do that 270 clockwise or 90 counterclockwise, I get to C prime. Again, I'm gonna flip these and change the sign of my y. So that'll be +3, -2. Right 3, down 2. There's C prime. Again, all these rotations are around our origin. That's what our figure would look like. Again, I'm going to show you how we can do this by hand. If we're going 270 degrees clockwise, that would be 3/4 turns to the right. So that it ends up with the top of your paper facing to the left, just like 90 degrees counterclockwise would. And again, I'm going to perform that up here with my software. I'm going to go 270 clockwise, same as 90 counterclockwise. This is what our figure would look like. And you'll notice all these points are exactly where they're graphed when we did it with our function notation. Point A is down here in what would be quadrant 3. It's certain units, 4 to the left, 5 down, right? B is just 2 to the left, C is 3 to the right and 2 down. If we remember these directions, that's where our points will be when we turn our paper back normal. So I've turned my paper, I see where my figure is on the graph after my turn, I recognize or remember where those coordinates are when my paper's turned, then I turn my paper back normal and I graph those coordinates. For example, here we'll talk about point B. It's an easy one. That's just 2 to the left of the origin when my paper's turned, 2 to the left of the origin. So when I turn my paper back normal, I'll go from the origin 2 to the left, and that is where B prime will be located. And you can just continue to do this 1 point at a time. So if I turn my paper back again, C is 3 to the right and 2 down. I memorize that, bring my paper back normal, and I go 3 to the right and 2 down, and that's where C prime should be located. So this is rotating by hand without memorizing the function notation. The next rotation we're learning about is a 180 degree rotation, which is the same thing regardless of if you're going clockwise or counterclockwise. Because 180 is 2/4 of a turn. If I'm turning to the right, I just get upside down. If I'm turning to the left 2/4 of a turn, I'm also upside down. So direction doesn't matter for a 180 degree rotation. It's the same either way you go. We have an example of a 180 degree rotation performed on the graph over here. Let's investigate what has happened to our coordinates. I'm going to look at point B here. Point B on our pre-image is located at +3, +1. B prime on our image is located at -3, -1. This is a pretty simple change, right? The 3 and 1 did not flip places. The only thing that happened is the signs changed. They were both positive on our pre-image, they're now both negative on our image. This will happen for every 180 degree rotation. Your XY will become -X, -Y. The signs are going to change from your pre-image to your image. As a reminder, every 90 degrees you rotate, a point moves 1 quadrant. So if we rotate 180 degrees, then our point is going to move 2 quadrants. And yeah, we can see how that occurs here with these points. B and C are both up here in quadrant 1. They rotate 2 quadrants down to quadrant 3 after 180 degrees of rotation. Point A is on the y-axis. It moves 1 axis, 2 axes to get to A prime. It's still 2 quadrants of movement. We're going to rotate segment AB here 180 degrees. It doesn't tell us which way to go, and again, it doesn't matter because clockwise or counterclockwise, 180 will result in the same position for our image. And again, if we're following our function notation rules, if we memorize these, we know that all we have to do is change the signs of our X and Y coordinate to perform a 180 degree rotation. So our pre-image point A was located at -3, +4. If I rotate that 180 degrees, both signs are going to change. So the -3 will become a +3, the +4 will become a -4. The image for A would be at +3, -4, right there. For B, our pre-image was located at +2, -3. If I rotate that 180 degrees, I just change the signs of my coordinates. So the +2 becomes a -2, the -3 becomes a +3. That gives us -2, +3 right there. There is B prime. And I can connect those like so. That is a 180 degree rotation. Oftentimes these 180 degree rotations can look funky like this one on the graph. It looks like they're almost overlapping each other. That's quite common with 180 degree rotation. It's also common to get it confused with a reflection in y = x or y = -x. So be careful when we're describing these transformations. I'm going to keep showing you by hand here because I think it's easy to do so. Here's segment AB. I can rotate this 180 degrees. Remember, the direction doesn't matter for 180. So I'm going to come in here and put 180. Notice that flips it upside down, just like it would for you holding graph paper at home. You do a quarter of a turn and another quarter of a turn, that's 180. So your page should be upside down. And again, I'm just taking note of where my points are now, imagining that I haven't actually turned my paper. So here's my origin. Point A now is 3 to the right, 4 down. I can just memorize that pattern, 3 right, 4 down, turn my paper back normal, and from the origin go 3 right, 4 down, and graph A prime. It's the exact same location as using our function notation. Then I'll go back and do the same thing for point B, right? So we're upside down. Point B from the origin is 2 to the left, 3 up. I just memorize that pattern, right? And I go from the origin 2 to the left, 3 up, and there's B prime, exactly where we expected it to be, right? Might be a little bit easier to remember how to do this by hand versus memorizing the function notation for these rotations. Another example here of a 180 degree rotation. Let's see if you can do this one on your own. Go ahead and pause the video and see if you can rotate these points 180 degrees on this graph. Okay, let's see how you did. If we're doing function notation only, we know that our points are just going to change signs. So that -5, +4 for point A will end up at +5, -4 for A prime. So that's 5 to the right, 4 down. That's right there, A prime after 180 degrees of rotation. B was at 0, 2. Again, if I change my signs, technically the 0 doesn't have a sign. There's no positive or negative, so it just stays 0. But then that +2 becomes a -2. So that B will end up here, B prime. Our C started at -2, -3, and again, 180 degree rotation requires us to change the signs of our coordinates. So that'll end up at +2, +3, right? 2 up 3, there is C prime. This is the image after 180 degree rotation. The last rotation we're learning today is a 270 degrees counterclockwise, which is the same as 90 degrees clockwise. Again, I'll use my paper to demonstrate. Remember, every 90 degrees is a quarter of a turn. So if I'm going counterclockwise, it's turning to the left. So here's 90, the top is facing me. That's 180, top is facing down. And there's 270 where the top is facing the right, which is the same as 90 clockwise. If I start here and I go right a quarter of a turn, 90 degrees, top is still facing the right, okay? So if we're doing this by hand, 270 counterclockwise or 90 clockwise will be the top of your paper facing the right when you rotate. And we have an example of a point being rotated 270 counterclockwise. Let's investigate the change here of the coordinates. Our pre-image was at +2, +1. Our image became +1, -2. So the values switch places, X and Y switch places. That X coordinate went from positive to negative, so the X changed its sign. The Y coordinate stayed the same sign though. So the function notation here that's gonna happen for every 270 degree counterclockwise rotation is X and Y switch place. The Y keeps the same sign, the X changes its sign. So XY becomes Y, -X. Keeping in line with our patterns here, every 90 degrees we rotate moves 1 quadrant. So 180 is 90 twice, so 180 moves 2 quadrants. 270 is 93 times, so we're gonna move 3 quadrants for every 270 we rotate. And we see that happened here. A started up here in quadrant 1, and it went past 2, past 3, ended up in quadrant 4 down here. It moved 3 total quadrants. In our first example here, we're graphing segment AB with point A at the origin at 0, 0. Point B is at -3, +5, that's up here. So here is our pre-image segment AB. And again, we're going to rotate this 270 degrees. It doesn't say which way to go, so remember that means we go counterclockwise. And again, the function notation that we just learned here is that our X and Y are going to switch places, and the X coordinate is going to change its sign. So point A started at 0, 0. That transforms into A prime. Remember, zeros don't have signs. They're not positive or negative. So switching these just results at the same location. So this is still going to be A prime. All right, for our point B, we will have changes to our coordinates because we have values here, -3, +5. That'll transform into B prime. And again, my X and Y are gonna switch places. My Y sign is gonna stay the same, so +5 stays +5. My X sign though is going to change. That -3 will become +3. So B prime is gonna end up at +5, +3, which is right there, B prime. That is 270 counterclockwise. Our next example is asking us to go 90 clockwise, which is exactly what we just did. It's the same thing as 270 degrees counterclockwise. So you're responsible for knowing about these directions, which of them are going to end up giving you the same function notations. So 90 clockwise is the same as 270 counterclockwise. We're going to be doing the same function notation switch where the y's switch with the x's and the x changes its sign. xy becomes y, -x. Our pre-image point A is located at -5, +4. So our change will give us A prime, where that y coordinate comes up front, stays the same sign, so it stays positive. That x coordinate switches to the back and it goes from negative to +5 because that x coordinate has to change its sign. So A prime is going to end up at +4, +5 here, right 4 up 5. There's A prime 270 counterclockwise. B is located at 0,2 on our pre-image. B 0,2. If I change that into B prime, going 90 degrees clockwise, again, same as 270 counterclockwise, my X and Y switch. Remember, the Y keeps the same sign, so +2 stays +2. The X changes signs. Zeros don't have signs though, so it stays 0. So B prime ends up at 2, 0, right there. B prime. And then C on our pre-image is located at -2, -3. Following my function notation rules, again, my X and Y will switch. My Y coordinate keeps the same sign, so -3 stays -3. My X coordinate changes its sign, so it goes from -2 to +2. So C prime is at -3, +2, that's right there. And there would be our image after 270 degrees of rotation counterclockwise, which is the same as 90 degrees clockwise. Again, very common for our figures to overlap like this with rotations. Okay, one last time I'm going to show you how to do this by hand here. We have this triangle that we're rotating 270 degrees counterclockwise, which is the same as 90 degrees clockwise. So I'm going to go here and put 90 clockwise. This is our result. Again, like we talked about, for that is a quarter turn to the right. Top should be facing the right. Then again, with one point at a time, seeing where our points end up. For example, A from the origin is 4 to the right and 5 up. I remember that pattern, bring my paper back normal, and I can go 4 to the right, 5 up to graph A prime, which is exactly where we graphed it with our function notation. Go back to get point B. It's 2 to the right from the origin. Just memorize that, bring my paper back normal, go 2 to the right, there's B prime at 2, 0. Go back for point C, that's 3 to the left, 2 up, and memorize that, bring my paper back normal, and I go that same direction to get to C prime, 3 to the left, 2 up. All right, we have a composition of transformations to perform now. We're gonna rotate 90 degrees. It doesn't say which way to go, so we're gonna go counterclockwise. Then we're gonna take our image and translate it. XY becomes X plus 2, Y minus 4. So first we need to remember the rule for that 90 degrees counterclockwise. That would be XY becoming negative YX. So 90 degrees counterclockwise is when the Y changes its sign, not the X. So for one point at a time, A on our pre-image is located at 1, 1. That'll end up being negative 1, 1. All right. Point B on our pre-image is at 5, 1. That'll end up being negative 1, 5. And point C on our pre-image is at 3, 4. That'll end up being negative 4, 3. We'll go ahead and graph those points. So there's negative 1, positive 1 for A prime. B's at negative 1, positive 5. There's B prime. C's at negative 4, positive 3. there's C prime. So that's the first transformation done. That's the 90 degrees counterclockwise. Now I'm taking all my points and performing this translation. Remember, the translation is the slide. X plus 2 means to go right 2. Then y minus 4 means to go down 4. So 1 point at a time, right 2, down 4 from our most recent figure. So that's ABC prime. So from point A, I'm going to go right 2, then down 4. And that'll lead me right here. Remember, we would call this now a double prime. Again, just 1 point at a time to perform these transformations. B, 2 to the right, down 4, ends up where our original point A was. Right there, it'd be double prime. And then lastly, point C, 2 to the right, 4 down, ends up here at -2, -1. That's C double prime. That is a composition of transformations, more than one on the same graph. We, of course, need to know how to describe rotations, which could be a little challenging visually to understand that a rotation has happened on a graph. Sometimes it'll be obvious that a turn happened. Like this figure has like a spike here to the top left, and that clearly is turning. It looks like our shape has just rotated to the left here around our point. So we know a rotation has occurred here. Remember, the rule we would then have to provide is how many degrees did it rotate and in what direction. And the thing that'll help us here is remembering that fact that every 90 degrees our quadrant rotates, it moves exactly 1 quadrant. So our pre-image started here in quadrant 1. It's gone counterclockwise 1 quadrant over. 1 quadrant of movement is 90 degrees. And because we're turning to the left here, that's counterclockwise. That's a rotation of 90 degrees counterclockwise. In our next example, we're again describing a transformation. We need to know the type first. And this one could be a little bit more tricky. Maybe 180 degrees rotation. I'm sure some people might look at this and think maybe it's a reflection in y equals -x. To know for sure, we can remember that those lines of reflection are found from the midpoints of our pre-image and our image. So the midpoints for A and A prime would be here at 0, 0. The midpoint for B and B prime would also be 0, 0. The midpoint for C and C prime would also be 0, 0. They're all the same location and not different points. They would all be different locations on a reflection that we would be able to draw a straight line through. Okay, because they're all the same point here, it's a sign that this is a rotation. Our pre-image started up here in quadrant 1. And it ended up here down in quadrant 3. That's 2 quadrants of movement, so that's a 90 twice, which gives me 180 degrees of rotation. And remember, for 180, it doesn't matter which direction we're talking about, clockwise or counterclockwise, it's the same. Lastly, we're describing a composition of transformations here. The key here is identifying your pre-image, your original figure, which is this teal triangle ABC. Then our first image would be the purple one, the one with only 1 apostrophe, not the double prime. That's the last figure. So we're describing this transformation first. And again, if I'm confused about maybe a y equals x reflection versus 180 degrees rotation, we can always do our midpoint thing, and we'll find all these midpoints would be 0, 0. So this is a rotation first. And because all of my points moved from quadrant 2 to quadrant 4, that's 2 quadrants of movement, that would be 180 degrees of rotation. Again, I could say clockwise or counterclockwise. That direction does not matter at all. All right, and by the way, let me go back to this one. When I said 90 degrees clockwise, it would also be acceptable to say 270 clockwise. 90 degrees counterclockwise is the same as 270 clockwise. 180, it doesn't matter. You don't have to give me the direction because it's the same either way. The second transformation then, now we're going from purple to red. And you can say, yeah, that's 1 quadrant of movement, but this would not be a rotation because here, if I found the midpoints of all my points, they'd all end up here on the x-axis. This is actually a reflection. This is a flip over the x-axis. That's the line that I highlighted there. So we have first a rotation of 180 followed by a reflection over the x-axis. Guys, this wraps up our lesson on rotations. We'll see you in the next one. Bye.